this become red. There we go. No one moved too much. All right. So like I said, we're going to kind of focus on the midpoint and distance formula, but we'll go ahead and kind of recap our first equations up here. Now, these formulas are all ones that you need to have memorized. Most likely, you probably already have these memorized, but the midpoint and distance formula, you need to add that to your noggin. Probably in a stinger, I'll show you how you can actually derive the distance formula. Pretty neat. You won't be expected to do that, but it could be helpful if you forget where the pluses and minuses are. Okay, so let's just first talk about this. So we've got standard form, slope-intercept form, and point-slope form. Slope-intercept form is probably the one you're most familiar with. It's often the one we use the most in middle school. Now, standard form has a couple of specifics that we have to follow in the formatting of it. Does anyone remember what those specific rules are? Oh, hold on, I need to practice names. You want?
It can't be a fraction.
Good. What can't be a fraction?
X, Y.
Close, very close. The coefficients in front of the x and y. Okay, so A, B, and C cannot be fractions. There's something else it cannot be. What do you say? Hold that thought, not quite. Decimal. Good. So it cannot be fractions and cannot be decimals. So let's go ahead and classify that as A, B, and C must be integers, right? What are integers? Go ahead, Jim.
Positive and negative numbers above 0.
Yes. Let's go ahead and say positive, negative whole numbers. Would you agree with that? Good. So let's go ahead and write that in. A, B, and C must be integers. Must be integers. All right, and I think I saw were you the one that said something about negative?
Yeah.
Okay, so there is a condition that has to be, it has something to do with negative. Remember what it is?
The coefficient for x can't be negative.
Very good. So A must be positive. Must be positive. I should probably actually write out A. Now B and C are okay to be negative, because sometimes you're going to have a negative within your equation. So our standard way of writing is that leading coefficient must be positive. All right, good. Now standard form, I feel like it's probably the least likely to be used. This is best for when we're trying to graph. You can graph using just the x and y intercepts, but really the slope-intercept form and point-slope form are most common. Now point-slope form, I feel like up until now doesn't get a whole lot of attention, but this is something that you'll actually be using when you get to calculus. This is the form that we use. We always write it in point-slope form, never really in slope-intercept form. So point-slope form, we've got our point, intercept there. Nothing really too fancy with that. All right. Just to kind of get you warmed up, I want you to go ahead and do numbers 4 and 6. Find the slope of those two guys. Now in this class, I do want you to collaborate with one another and utilize each other. So when you're done and you've found your answers, go and check with someone nearby you. Just check with that person behind you or in front of you or next to you. Make sure you got the same thing. If you're ever stuck, talk with those around you, glean from them, raise your hand, I can come help you. But there's only one of me and a lot of you, so use those people around you to help you out as well. But I do want you to go and check with each other, see if you got the same answer. And if you didn't, talk about it. See what you can fix to make it right. Alright, let's go take a look at number 6 first. What form is this currently in? Yeah, standard form. Now, and when we look at standard form, we see that we don't have m, which represents slope, anywhere in our equation there. So what can we do in order to find the slope with number 6? Okay.
Isolate the y.
Good, isolate the y. I love that you use that math word, isolate. Good. We want to isolate the y, which means get it by itself. So would you guys agree you subtract 8x from both sides? Okay, so we have negative 2y equals negative 8x minus 3. And then again, we want to get y all alone. Isolate that guy. So divide it by negative 2. Be careful that you don't lose your negatives. That is probably one of the biggest mistakes I see across all math classes. Alright, so what do we get for our slope-intercept form? 4x. Yeah, 4x plus 3 halves. Now, in here we will get fractions. We sometimes will get decimals. We will get radicals. We will get those numbers that they were so nice to not give to you in your former classes. So don't be alarmed if you get a fraction. Just double check your work real quick that you did it right, but don't be alarmed. Now, I will most likely write my fractions as improper fractions. You are welcome to write as a mixed number 1.5, but I honestly prefer that improper, which is that one number. If you're at 1.5, that's fine, but you should never be rounding unless I tell you to. So, for example, if it was 1/3, do not write 0.3. Because 0.3 is not 1/3, that is 3/10. So if it is a fraction, leave it as a fraction. If it's just easy enough conversion to a decimal, like this 1.5, that's fine. Alright, now we didn't actually answer the question, we just got in slope-intercept form. So what is our question? Find the slope. What is the slope? It's our slope. Any questions on that one? Alright, now with number 4, did we have something funky happen? Ish, kind of funky. Yeah? Alright, what did we get when we did our slope formula here? What was our simplified fraction? 2/0. So when we did, I'll go ahead and set this up for you. So y minus y, 6 minus 4, over x minus x. Negative 6 minus a negative 6 plus a positive. That gives us 2/0. Alright, does anyone know who Chuck Norris is? Okay, thank you. There are a few of you. Every year, it's favorite for your students. Chuck Norris is the only one that can divide by 0. No other mere mortal can, only Chuck Norris. You are not Chuck Norris. You cannot divide by 0. So what do we call it when there is that 0 in that denominator? Undefined. Good. So here we would say our slope is undefined. It is undefined. Now, if you leave it as 2/0, that is not sufficient. I need to know that you understand that that means undefined. Okay, so anytime it's divided by 0, it's undefined. So here our slope is undefined. What does that mean for our slope to be undefined? What is my line going to look like?
Vertical.
Good, it's going to be vertical. Let's go ahead and throw that at the top here. So vertical line, slope is undefined. So vertical line, that slope's undefined. Which, if we think about those points, that makes sense. Because if we look, the x value was the same. If I were to graph that, it'd be something like this. When I go to calculate my slope here, it's rise over run, so I rise 2, and I don't go anywhere to the left or right. That's why we get that 0 in the denominator. So that means is that your line didn't get slanted to the left or right at all, so it is that vertical line. Now, what about a horizontal line? What's the slope for a horizontal line? Okay. So horizontal line, slope is 0. which again, kind of that same thinking. I really want us to practice thinking through these concepts, not just memorizing stuff. A horizontal line, if I take 2 points on it, I rise 0, and I run however much left or right. So that would be 0 divided by a number, and 0 divided by anything, 0. So we get our sums. Good. Alright. Let's see. Gosh, I'm pretty good with all of that. Alright, let's take a look at part 2. So write the equation of the following lines in slope-intercept form. Everyone's favorite. Let's go with 7's too easy. Let's do number 8. Alright, number 8, we can tackle this a couple of different ways. You see, they tell us a line through the point and slope of -3/4. Now, if I look at my equation here, they gave me the slope. We have our m value, but do we have the b value?
No.
No, what does that b value represent again?
Y-intercept.
Y-intercept. They did not give me my y-intercept. So what can I do to get this information in this form of equation? Any thoughts? Good, point slope form is the way. Now what is another way that we can do? Go ahead. Good, what values are you talking about?
The x and y.
Good. I can take my x and y values here, substitute them in for x and y in my equation, as well as the slope. That leaves b as my only unknown variable, solve for that, and then put it back into my equation, write out my equation. Either way works. Honestly, they probably take about the same amount of steps. Personally, I like the point slope form. I like to take point slope form because, I don't know, it's already in that format, and you don't have to substitute anything back in, you just solve for y and simplify. So whichever method you prefer to do, go ahead and do that, and I want you to go ahead and do number 8 there. Again, once you get your answer, check with someone nearby. See if you got the same thing. More conversation where we can turn and share with someone nearby. All right, does anyone feel confident enough in their answer to share it with the class? No. Lucy?
Y equals -3/4 x plus 17/4.
-3/4 x plus 17/4? Do we agree?
Yes.
Very good. See, we got some fractions and even an x prime there, 17. Good, very good. -3/4 x plus 17/4. So again, don't be alarmed when you get fractions. Just double check it if your math right. We'll see fractions a lot. right, any questions with that? Okay, let's flip it over to the back side. Let's take a look at part 3. So part 3 is find the distance and midpoint of the following segments, and leave answers in the radical. So you will always leave your answers in simplest radical form. Again, we won't be using calculus, so I should see a simplified radical, not a decimal value, unless I ask for it. And make sure you show all work. So to kind of get us warmed up, let's just go ahead. I want you to squeeze this in here. Find the square root of 128. I want you to simplify that down. Just going to squeeze that in on your paper, just to kind of get warmed up with radicals. Remember, we're looking for perfect squares and primes when we break that down to help us out. Okay, anyone want to offer up their answer? Cameron?
6 times the square root.
6 times square root of 2. Do we agree with that?
No.
No? What would you change?
8
8 where?
instead of 6.
So 8 root 2?
Yeah.
Are you good with that, Cameron? Okay, so let's take a look at this. 128, decently big number, but we see it's even, so might as well try breaking it down by 2. Usually if you do 2s, it takes forever the whole way, but at least at a starting point, let's break it down. So we have 2, and what's half of 128?
64.
64, and then you cheer and say, woohoo, we know the square root of 64, we don't have to keep going for forever. So square root of 2, we do not know, so we put that, we leave that underneath radical. Square root of 64, we do know is 8, and that's what comes up right. Good, so 8 root 2. Alright, now distance formula, again, has that radical, so you will see a lot of radicals with that, so that's why I want to go. So let's go ahead and just rewrite our distance and midpoint formulas. Our distance formula is the square root, now I want everyone to write this on that paper, x2 minus x1, quantity squared, plus quantity y2 minus y1, that quantity squared. Okay, so again, it's the square root of the following. X2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now, a couple of things to be careful with as you're memorizing this formula. Common mistakes I see, sometimes students will add the y's and x's instead of subtract them, so we want the difference. Sometimes they put a minus sign here instead of a plus, but they multiply it. And then kind of the biggest thing is set it up right. We'll do all the math and simplify inside, and then forget the square root at the bottom. So make sure you're rewriting that square root each time until you actually evaluate that square root. All right. Now our midpoint formula is actually the average of our x's and the average of our y's. So it is x1 plus x2 divided by 2. That's the x coordinate. That's going to give me one single number, and that will be my x value. And then for my y value, so comma, y1 plus y2 divided by 2. And again, that will give me one single number, which will be my y value. So take note that the distance formula is giving me a single number. The distance formula is finding the distance or the length between 2 points. Okay? So, for example, on that previous problem, I could use the distance formula to find the length between these 2 points. Now, obviously, we could count it faster, and use math reasoning there, but when it's all stretched out or slanted, it won't be so easy. So I'm finding the distance between 2 points. If I were to get out a ruler that measured in graphing units, I can measure that distance there. Now, the midpoint formula, as we said, notice that this is an ordered pair. So my midpoint is an xy coordinate point. What it is it finds that halfway point, the midway, the midpoint, the halfway point between our 2 points of question. You might get fractions for this. It could be a whole number, it could be a fraction. Now, sometimes if we had the point, we could easily just count figured out, but it's not always going to be that easy. So you do need to know how to manipulate this algorithm. But I do want to emphasize that this is an ordered pair that it gives us. This simplifies down to one single number, which is your x value, and this simplifies down to one single number, which is your y value. Okay. So let's just go ahead and dive into that first example. Just straightforward, use the distance formula and the midpoint formula. All right. So number 13, it's a segment with endpoints 0, 0, and 3, 2. So they gave us the two endpoints. You can even think about it visually. We've got something at the origin and then something like this. We want to find the distance of this and where the halfway point is. All right, now this is pretty nice because we got that 0, 0. The math will be quick, but we want to go and set it up. Distance equals the square root of 3 minus 0, quantity squared, plus 2 minus 0. Now I know that you're going to be able to do some arithmetic and algebra in your head, but I do want to at least see the setup before your answer, so I can see that you at least set it up correctly. Now this one's going to be kind of easy to simplify. 3 minus 0 is 3, 3 squared is 9, and don't lose that square root. 2 minus 0 is 2, 2 squared. So what is our final distance?
Square root of 13.
Good, root 13. Can I break that down at all? No, 13 is a prime. We can't even break down 13. Good, so our distance is root 13 units. Do you guys know approximately how much root 13 is? I like that. That's close. I love approximating radicals. Root 13 is in between what two perfect squares?
3, 4,
Good, 9 and 16. So that means that the value will be between 3 and 4. It looks like it's halfway-ish. I don't know, so maybe somewhere around 3.6-ish. But I don't ever want you to write this unless I ask for a decimal. But it's good to have in mind, particularly later on in the year when we're doing triangles, to know approximately what that length is. All right, so square root of 13, 3 point something is going to be our distance. All right, pretty basic, straightforward. Midpoint, just as easy. All right, so my midpoint. Again, now we are adding the x's. It's the midpoint, halfway. You want to find the average of the two x's. So 3 plus 0, or 0 plus 3, does not matter. Divided by 2. And then 0 plus 2 divided by 2. And again, we simplify. This gives me one single number here of 3 halves. This gives me one single number. So my midpoint is simply the point 3 halves, 1. Which if I were to graph that out, do 1.5 over, 1 up, that'd be it. Alright, so again, distance midpoint formula, really the trickiest thing is remembering the formulas. They're really not that bad. Now again, you need to make sure you do have these formulas memorized, especially by next class. We're going to be using it right away. There's something else I want to say about this. Okay, so I want you to go ahead and try number 14 here. And just find the distance and that midpoint of those two endpoints. B lunch has ended and now C lunch is going. But we're getting there. to get your answer done, check with the person nearby you. Just make sure you're on the right track. Alright, what do we get for our distance for number 14? Very good, square root of 61. Quick approximation on that. Yeah, probably like 7.8-ish. Close to 64, so just under 8. Alright, and what do we get for our midpoint? Good, negative 11 halves. And negative 3. Good. Alright, any questions on this? Alright, so now we're going to rack your brains a little bit. Go ahead and take your packet and flip it over to the back side, which is blank. Alright, so we're going to continue dealing with distance and midpoint. So let's go ahead and rewrite it, again, just to kind of keep working it into our brains. Let's write our distance formula. It's the square root of x2 minus x of 1, quantity squared, plus y minus y quantity squared. All that square root. And our midpoint formula is again the sum of our x's divided by 2, comma the sum of our y's divided by 2. So our distance formula and midpoint formula. Again, these are to find the distance between 2 points. What's another word for distance between 2 points? Length. Yeah, good. Length. The length that distance covers. And the midpoint, the halfway point between those 2 points. Alright? Now, suppose we have this. A segment. I want you to go ahead and write this down. A segment has an endpoint. Segment has an endpoint at -6, -1. And its midpoint has an endpoint at -6, -1, and its midpoint at -3, 1. So now we would say that for one end, it's given to us, but instead of the other endpoint, it gives us the midpoint. So find the other endpoint, and then on top of that, we're going to find the distance of the whole segment. So find the other endpoint and the distance of the entire segment. Go ahead and put in the word length there just to kind of help you make that connection. Distance or length of the entire segment. Alright, so slightly different scenario. We now have an endpoint and the midpoint that's been given to us. So we're going to use that information in our formulas up there to try to find the location of that other endpoint, as well as the distance of the entire segment. Now what I'm going to have you do is I want you to take about half a minute to look at it and think to yourself, and I'm going to kind of group you up and have you work with one another to come up with a plan of how you can go about doing this. So right now I just want you to go ahead and kind of look at it, think through it, think of what you could do, so you have something to kind of contribute to the group. Alright, now I'm going to go ahead and kind of group you up in groups and pairs. Unfortunately, because of how many people we've just squeezed into this classroom, the rows are kind of crazy. But let's go and go you four work together. We'll go you four work together. We have these four, and then I want you two. Then we're going to go you four work together. Two will work together. So with these four, so therefore and then you two. So I want you to talk, literally turn and talk with one another about how you can go about doing this and actually go and try to solve the problem. Right. I love hearing all this discussion. This is good. Alright, so let's talk about this. I want to hear what some of your thoughts are, how you went about this, what we did. You could have started off by either finding the distance first or the midpoint first. You didn't have to do one before the other. Raise your hand if you found the distance first. Raise your hand if you found the midpoint first. Okay. What about the rest of you guys? Alright, so you really could have tackled either one first. Does anyone want to volunteer what they did dealing with the other endpoint? How they went about finding that? Okay, hold on, I need to work on this.
So you would, I found it easiest with the midpoint formula.
Okay.
And where it says MP, you plug in -3,1.
Good. Okay, so did you hear what he said? He said you take your midpoint formula, and since we do know our midpoint, you go ahead and substitute that in. So let's go ahead and do it. So I have my midpoint was -3,1, and it equals this over here. So we've got our midpoint. Do we have any other information? Yeah, we have our x1 and our y1, right? This here is one of our endpoints. Honestly, you could put in for x2 if you really wanted to, didn't matter. But we can go ahead and put in these values here. So then x1, -6, plus x sub 2, divided by 2. And then -1 is my y sub 1. So -1 plus y sub 2 divided by 2. Alright, so we know our midpoint, and we know one of our endpoints. Now, does anybody see what we can do from here?
Wait, I have a question. Why is the one negative?
My endpoint is -6, -1.
Oh, okay.
So I can just take that by that. But over here, this one is.
Okay.
Alright, so any thoughts of what we can do next with this? Iman?
You can like multiply everything by 2 to get rid of that.
Okay, I like what you're doing, but I don't know that everyone's seeing the connection you're quite seeing there. I'm kidding.
You can cross multiply.
You can cross multiply, but I want it, so what are we cross multiplying? What are we putting together? I see people wanting to raise their hand. They're so close, but they're so scared to. Go ahead, Julie.
I have a different way like to do it.
Okay, hold that thought. I want to hear it in just a moment. So what I want to make sure we understand here is this is an equation, right? What we really have is 2 equations in one. My -3, that's the x value that equals this x equation. So in Iman and Ankit, we're talking about multiplying by 2 or cross multiplying. They're talking about solving that equation. So let's go ahead and set up that equation. -3 equals this x equation. -6 plus x of 2 over 2. See how we have that equation there? So now it's just a normal equation. Similarly with my y's, this is the y value, this is my equation for the y value. So I can again set up my equation. 1 equals -1 plus y sub 2 divided by 2. I feel like that's kind of the trickiest part, is to see that connection there. That this is actually, I feel like some of you students struggle to say this is actually an equation. My x value equals this x equation. My y value equals this y equation. So we can set the equation dealing with just my x's and the equation dealing with just my y's. Can we see that there? Anyone have a question on that? So now we can go and do what you guys were saying. You could cross multiply by 2. I'm just going to go ahead and multiply by 2 on both sides. It's -6, so it's -6 plus x of 2. I'm going to add my 6 over, get 0 for that x value. Over here, I get 2 equals -1 plus y sub 2. Add my 1, and I get 3 for that y value. So then my other endpoint, that ordered pair, is 0, 3. Raise your hand if you got that. Awesome. Awesome. Now, Jalen, what were you saying that you did?
Okay, I don't know if I can.
Okay. Does anyone have another way that they want to do this? Go ahead, Tyson.
I found the slope first.
Okay. And they kind of counted from there, right? Awesome. So Faisal said, well, I can figure out the slope and then use that to find my next point. That's super good. Now, that worked out nicely here with our next one numbers. It gets a little trickier with the fractions. So that is definitely a good tool, but I want to make sure we all understand how to do it algebraically, because sometimes our numbers will be pretty funky and will make it not so good. Very good. Any other thoughts on that? Okay, so now distance formula. Now that we have both endpoints, you can just plug and chug. But did anyone find the distance first, and how did you go about doing that? Alexis, yes, no? Okay. Did anyone find the distance first that wants to share how they did that? Come on, I know there's someone out there that wants to. Go ahead, Amy.
So I was saying, like, if you found the distance between the endpoint and then the midpoint, then you could multiply that distance by 2.
Very good. That's perfect. So the distance between the endpoint and midpoint, since the midpoint is halfway, then that's going to be half the distance. So you find your distance, double it, you're good. You could, again, do it using both endpoints, but that was something you could have done without even knowing your other endpoint. So I'm going to go ahead and follow that here. My board's really going crazy with colors. All right, not midpoint, distance. So let's see, using my endpoint and that midpoint, -6 minus that -3, so -6 plus 3. You gotta be really careful with those negatives. Plus, and then, so this first, -6 minus 3, -1 minus 1. Alright, so -6 plus 3, -3, -3 squared is 9. -1 minus 1, -2 squared is positive 4. So our distance of that chunk, and I'm going to go and just write endpoint, midpoint, just so I know that that's the distance of just part of it, is the square root of 13. Now here's where we gotta be careful. We gotta remember our rules for simplifying radicals. So if root 13 is half of it, what's root 13 plus another root 13?
Root 6.
13.
So you're not 13.
Ooh, some variety of answers. Alright, raise your hand if you think root 26. Raise your hand. I don't remember that one I heard. 2 root 13. Raise your hand if you think it's something else. Raise your hand if you're ready to go to lunch. Yes. Okay, so when we are adding radicals, think of it this way. They have to be like terms. So if I have a root 13 over here, and I have another root 13 over here, how many root 13s do I have? 2. So it is going to be 2, so I'm going to write distance of entire segment equals 2 root 13. So it's basically 1 root 13 plus another root 13. Your term stays the same, and you add the numbers in front, so 2 root 13. Or 2 times root 13 is 2 root 13. Questions on that? Okay. So that's really the only way I feel like distance and midpoint formula can get tricky. Is kind of present it this way. Also, of course, if we throw in fractions, we have to do fractions within fractions. That's always a fun time. But really, distance and midpoint formulas is just knowing those formulas and plugging and chugging, simplifying. Just be very careful that you have that formula memorized properly and that you're careful with your names. Any questions on this? All right. Go ahead and on that back side, I want you to factor the following problem. Because factoring never goes away. Ever. Until you're done with your math classes. We will be using the regrouping method in here for our factoring. You probably were doing regrouping method without it knowing that it was regrouping. So just write this on the back side and read that last example. And once you get your answer, I want you to check with your people around you, see if you got the same thing.
Top and bottom, that's the multiply to the right, and I have to multiply to the right.
How do I get the numbers out?
Alright, we'll go over this one first thing next class. Your homework, as you see on your assignment sheet, is to finish this lesson 1 homework. And again, make sure you check your summer packet with the key that's up on Blackboard. I'll make that available for you guys today. So you can come see me if you have questions before that quiz. Next, I want you to complete the entire lesson 1 homework. And then once it's packed up, you can go ahead and head off to lunch. Let me go like 30 seconds. Don't expect it right now.
Well, it doesn't last forever. I was like, apparently there's like 30 seconds to really go up and go, and the bottom brain was like, you can go move like pop. Oh, you have enough of that.
Did I ever restart it?
What?